So we're gonna kick things off. If you have any questions come up throughout, feel free to drop them in the Q&A so we can keep track of them there. But welcome. Today we're going to talk about how Zapier uses detection as code to increase their alert fidelity. We'll start with some quick intros. I'll let you introduce yourself, Michael.
All right. I am Michael Kuchera. I am the security incident response lead at Zapier. Um, Came into Zapier about 4 years ago with the goal and intention of spinning up the security incident response and security detections capabilities in the company. So been a Panther user, I think, for around 3 years now at this point. So um, yeah, thanks for joining up and letting me talk all your ears off.
We're excited to hear from you. I'm Katie. I'm going to be the host and co-host with Michael today. I'm at Panther. I'm a product marketing manager. All right, so let's dive in. Oh, did not skip a slide. All right. Oh, thanks everyone for bearing with me, hitting buttons. We're going to start by tackling what are the challenges that modern security teams are facing that make detection as code kind of a good solution for them. The first is data. There's so much data for security teams to be monitoring, detecting on, just checking for threats. And especially as we've moved out of in-office settings, it feels like there's just more and more data. There's more and more SaaS products. So you want to be able to make sure that you can cover all of that data. You also want to make sure that you can ingest it somewhere easily, not at a high cost, be able to monitor it. How are you interpreting the logs? How are you normalizing that data to be able to monitor and search on it? The second big piece comes in around identity. This also comes back to moving away from in-office settings. We're not in traditional on-prem situations. The security perimeter needs to be at an identity level. So your employees, what tools they're using every single time they log in. These are really where we want to set the perimeter. So you have to ingest an alert on a lot of different types of sources. And so it can be hard to, again, kind of coming back to the data, it's creating that same problem. And then threats, of course. In security, there's always going to be emerging threats, but with today's modern challenges, especially with the rise of things like AI, we have crypto mining, there's so many different new challenges to be aware of and able to adapt to. Okay. We'll get into some more detail now on what the problem is with the traditional approaches to those challenges.
Yeah, so generally when it comes to traditional sort of approaches and looking at sort of traditional SIMs and the sort of technologies around things like the syntax and the queries and stuff like that, the logic itself is often, as kind of stated here, pretty simple in terms of you're flagging on strings, or you have aggregate functions that give you a count or some sort of data that you're comparing against like a static threshold. You also have logic generally defined as either like Boolean queries or some like esoteric, language that takes specialization to understand. Um, right? There's because of some of those limitations, you often are set up with a eyes on glass. Let's get a lot of people, a lot of bodies looking at alerts. There's no getting rid of false positives, right? We can try to reduce the rates and stuff, but generally, when you're without the capabilities that provided by something like a detection as code logic base, you're going to have a higher amount of false positives, right? So you have things like analyst fatigue, you have burnout, you have people filtering false positives just because they historically, that's what they do, right? Um, and tweaking those sorts of things is usually around custom lookup tables or lists that you have to maintain. And it's generally a very manual process, or it's a scheduled process. If I'm tweaking employee IPs, for example, I might run a script that gathers that once a day, updates something in a lookup table, and I refer to that for the alerts that day, or something along those lines. Which can lead to like out of date information. Um, gives you the problem of potentially missing accurate data within the context of your alerts. And anytime you're missing data, you're lacking something either accurate or missing that context. You're going to need to do that manually, right? You're going to trigger alert, which is going to give you slower response times. So you're going to the less critical and important contextual data you have up front, obviously, the more time you spend manually gathering that. So it really just leads to a slower response time as a result of that. Um, then as mentioned here with like the generic rules, there's always going to be out of the box alerts and detections and things for any sim. And to be most effective, I hope this is no surprise, you have to custom tailor these things to your environment. So the ease at which you can do that via the logic of the detection really is directly correlated with the quality of your alerts, right? If it's difficult to maintain an update, a generic rule, then it's not going to be done either as quickly or as consistently, leading to just overall poor quality. And I mentioned the sort of esoteric language of some of the traditional sim approaches, right? Which means you need to have generally a specialized skill set for that. Anyone who's written a super complex like Splunk query knows the feeling of like, yes, I was able to translate all of that, but also knows that you are the only person maintaining that for the rest of the life of that alert. So it's like, that specialized skill set is required to do anything really advanced, either in, that sort of Boolean logic of Lucerne syntax or something like traditional piped logic. So yeah, all that leads to the fact that here, like the Python-based detections, detection as code. Anytime you're using a more generic code-based language for logic, you get that generalized skill set. So yeah, we'll talk a little bit more about that in the upcoming slides, but
Yeah.
I think that kind of summarizes, I think, what I consider the big points,
Yeah.
pain points of traditional sims.
Yeah, it's a lot of problems. So how are teams adapting detection as code? It's really aligning with modern security teams wanting to overcome these problems. So what is detection as code? It's when detections are defined in code at its core level. So in this case, in Panther, we use Python. It allows for really straightforward rule creation and increased ease of use. You just heard from Michael about how challenging it can be to create effective rules, how hard it can be when you're stuck with a specialized language, especially in a tool like Splunk. It's rigorously tested. So a really important part of detection as code is the built-in testing. It makes it more effective and resilient when you're monitoring for threats, as well as scalable. And then it's important that it's consistently tuned and optimized. So detection as code is really an engineering first approach to detection and response, and where you're following those engineering principles and you're doing everything with code as much as possible. And it empowers your team. You can do more with smaller headcount. Michael just talked about the eyes on glass team of so many analysts checking every single alert. When you have improved detection efficacy, increased alert fidelity, fewer false positives, you don't need as many people sitting in those seats. So you can do more with less. It improves your alert triage and response when you streamline that detection engine. You actually have better detections, they're more accurate. You're not spending time on things that aren't really important for your team to put their eyes on. You can tune those out. And increases collaboration across your team. So there's a lot of benefits to your team, as well as just overall your security posture improves when you're following these principles with detection and response.
I'm going to just kind of add something to that I'm not going to
Oh
cover
yeah.
quite in detail going forward, but just to reiterate the idea of the testing capabilities of detection as code, right? Being able to validate and verify the kind of test logic before you push it, so that you're not realizing like, oh, hey, this test is broken because it's been 3 days and I'm not seeing the expected amount of traffic, right? This is stuff that with a proper setup for testing the alert definitions and stuff like that, you get a much better sense of whether or not your logic is correct right off the bat. So yeah, I won't go into that in too much detail, but I did want to just reiterate that since you brought it up, Katie.
Yep. Nice.
Cool. Yeah, so a little bit as to why we at Zapier implemented detection as code. When I came in, the program was in its infancy. We did not have a dedicated SIM tool. We were working with some pretty traditional approaches to things. And the sort of goal that I had when I onboarded was a few challenges and a couple of guiding principles, right? So obviously with any sort of SIM tool, you want centralized visibility. But what sold me on a SIM that leveraged a detection as code approach is that there's a lot of support for ingestion of just a slew of different log types, either right out of the box or easily done with standard like schema definitions on understandable and easy to read configurations that are generalizable. Again, it's not something that takes a specialized knowledge of a particular tool. Like if you know YAML, you're golden, right? If you know, and that was back in the day, I don't even think you need to do that now. I think Panther handles the bulk of that, but right, it was still a generic language and interpretation of data that can be leveraged, right? And then looking for something that allows us to normalize multiple log sources, right, into alerts. It gives us the ability to leverage a known system with complex logic in order to parse data types, right? When you're talking about a tool generating alerts that you want to send to your SIM, you might not be able to parse that data super accurately with, as it's just sending strings and strings of stuff. So with the detection as code approach, you get this stronger ability to parse, to manipulate, to ingest. So that visibility becomes a lot more expanded versus what my experience has been with some other solutions. Right, I had a new detection response team. At the start, it was literally just myself, so I had to, make do with something effective. I needed something that could have us hit the ground running, and I knew that I would be working with a very small and agile team in the future, and so I needed something that allowed us to really just be effective straight out the gates. I didn't want to have people go through, 8 weeks of onboarding training to understand and be proficient with the tooling, right? So we're able to take people with an engineering background or even just basic, like a 30-minute Python class, right? Is enough to give you enough information to be able to apply these sort of skill sets to detection logic. So so having that as part of the SIM was super important to me, and being able to leverage known coding languages. So and then as mentioned before, like it really leads to a flexible detection logic, right? It's looking at Python versus like Boolean queries of like, hey, this is a string that I'm searching on, and this, and this, or this, and this, or this. And if it's in this set, and like, so you have these really obscure strings that maybe you can figure out, but then rereading is terrible, right? Trying to parse those into what is the logic there is usually difficult when you're looking at things like Boolean or pipe logic. So being able to look at and develop, a small Python script that handles that, increases legibility, and increases the ability for other engineers to come in and tweak that logic and change bits and pieces here and there without needing to be the person that authored it. It really puts rule creation on a whole new sort of plane, where you now have things like you leveraging the Python libraries for HTTP requests to be able to reach out to internal tooling. Like, instead of doing a lookup list of users and their associated IPs, I can literally query Okta as a part of my detection logic and pull that in to get that point in time that will not change. It's baked into the context of that alert. And I don't have to worry about that rolling over or being updated somehow. Like the programmatic part of detection as code, leveraging a scripting library for your detection logic has increased what we've been able to do in terms of just contextualizing alerts really, really well. And I know I just saw a question come in, so I want to make sure we can
I
get on
think
that before I
that
start
our
ranting.
next slide will answer that question
Oh,
effectively. How has the implementation of Panther benefited your detection and response team? We can flip over to results from detection as code in Panther.
yeah. So great question. Appreciate that. And it moves us in pretty nicely. So the improved alert triage and response really comes down to a couple of key elements of what I kind of talked about with the benefits of that coding language and that flexibility. Right, like with Panther, we're able to create these dynamic playbook steps. So we can take an identifier, and we might not have a link in an alert from like an EDR tool or um, an IP, but we're able to then generate as part of this dynamic playbook, like, hey, if we want to check out the who is info, we can actually generate that link programmatically and insert the indicator. We can take the you know identifier for a piece and plug that into a preformed link for a dashboard so that our analysts don't have to go into a tool and look things up. Our playbook steps are dynamic and can bring people to where they need to be as they're triaging this alert. We also do things like the severity assignments. For a lot of things, you don't need to have necessarily any complex logic determining severity. You know that if you see certain number of errors on an AWS API, scan, like, okay, someone's doing something they shouldn't be doing. You don't need dynamic severities there. That's probably something you want to look into that's pretty high severity. But there are a number of things like internal employee actions where the context of an employee's role within the company may determine whether or not something is more severe or less severe. And you can use this sort of dynamic severity capability within Panther and just with detection as code, again, using Python logic to kind of track the historic usage of roles and the historic API invocations of a particular user and compare against those as thresholds, right? And again, you can programmatically reach out and pull a user's role and be like, does this make sense? So if it's not within our security teams or our SRE teams or production engineering, right? And they're accessing AWS directly, like maybe we want to rate that as a higher severity, right? So you get this capability to really leverage the logic, the complex logic capabilities of Python and just scripting in general to add that context and add some dynamics to the overall alert results. It's actually been super awesome for us to be able to, and it's helped us prioritize for a small team what we're going to triage first, right? Dynamic severities is key. And I mentioned kind of that programmatic access to other tooling. The helpers, like if you do reach out to Okta a lot and do something, write a helper for it. Then you just import that into an alert definition and it's there, right? It's just an import basically. And so the more of those you have that can abstract away more complex logic, the easier your life is going to be in terms of implementing that complex logic because it's no longer complex. It's just an import, for example. All right, that's one. I tend to ramble, so I'm gonna breathe here. All right, then yeah, reduce false positives. I kind of mentioned this in terms of the dynamic capability of reaching out and grabbing context or analyzing alerts and pulling in data from third parties or historic information really has helped us contextualize alerts in a way to better reduce false positives, right? We're able to be like, all right, let's be really specific about what APIs are allowed by certain roles and not alert on those. We might throw it as an info, so it's there if we ever want to look at it, but it's just, it's nothing we have to worry about. Things that would otherwise be like, okay, this is yes, it's a real action that was taken, but it's part of their role. So just call it an FP or call it triage or whatever, right? It eliminates that whole class of sort of human action that gets taken. And again, like the code structure really makes the logic of detections easy to adjust, easy to, like I said, for somebody else who didn't write it to come in and modify it, which is not going to be the case generally for more advanced queries in other languages. You really, it takes a lot longer to understand what's going on. So, and because of all these improvements, the security posture overall at Zapier has been improved, um, because we've been able to more effectively triage, more effectively address, whether that's misconfigurations or security events that come in. Everything, it allows us to kind of filter that through our pipeline a lot easier. So, all
Nice.
right.
And I know we have some questions coming in. We're not ignoring you. We are gonna continue on with the slides, and we're gonna make sure to dive into Q&A when we wrap those up. So keep the questions coming. We see them. Thank you. And we will make sure to get to them at the end. So we're gonna talk now a little more tactically. We've talked a lot about how detection as code can help at a high level, and what does it look like in some more actionable steps. So we're gonna start with analyzing your environment for threat coverage gaps. So the first step is really assessing your current landscape. So what do you have in your security environment as far as your tools, your log types? What do you need to be monitoring? But you need to understand the threat landscape and then identify techniques for finding the gaps in your current threat coverage. I'll let Michael talk more about the specifics, how to do that.
Yeah. So if you haven't done a gap analysis of like your log sources or your like visibility analysis, analysis is what some places might call it, and you haven't looked at kind of your tooling and what you're logging, it's an incredibly important step. And there's a screenshot here on this that is a sanitized version of one of ours at Zapier, where it just kind of shows, right, kind of a little bit of how we track this. It doesn't have to be fancy. It doesn't have to look great. It's a busy spreadsheet, right? We got color coding because that's as fancy as I'm going to get with that. But when you're performing a gap analysis, basically what you want to do is go through and, right, find out what your systems are that you're leveraging across the org. Some of them you might not even think have relevance as a security, input. Put them in the spreadsheet, right? Try to track every piece of information you can. And that might be just as you come across them, putting them in there. It might be going to tools that your procurement team has and trying to import lists that way. Soliciting teams like, hey, production team B, like, what are you using for tools? Like, where do you send data? How are you developing? Um, and kind of filling it in that way. But then also, right, if you're running security incidents, odds are those are going to involve tools that are a part of that. Make sure that, whether it's the cloud providers or the dev environments or your CI/CD tooling or anything along those lines, try to track that stuff. And in particular, what we track here, right, is we track the overall like tool or environment. So in the screenshot, you can see some AWS, and we track like WAF logs, Route 53, Lambda API, like all these stuff that come into that. And you can do that for all your tools, break it into as many sort of subcategories as you want, right? We call it resources and log types. So AWS would be the resource, and config events would be the log type. And then we break it down into, do we have these logs available to us? All right, are they being ingested somewhere? And then are they available for alerts? Right. So are they good for generating alerts? Yes or no? Maybe. Are we not sure? Are they good for contextualizing alerts? Right. Some things you might not want to alert on, but allows you to pull in data from that tool to provide more actionable intel to the alerts that trigger. And this is one of the sort of pieces that I don't see a lot of teams leveraging when it comes to doing a gap analysis, but it's helped us at Zapier really look at what can improve our process. Because we're using, detections as code, we can reach out and ping some of these tools and pull that in just via API requests, right? So And then just note some gaps, note some notes about the source. So it's not terribly complex, but I would recommend absolutely tracking things like, what are your tools? Are they logging anywhere? Can it be used for alerts? Can it be used for context? And that's that core data. And then obviously any notes that you have for that. So, and then you want to take that and kind of prioritize based on your own internal needs.
Nice. So yeah, take home action, try performing a gap analysis in your environment. See where you have those gaps, and start putting it to work. So when it comes to actually planning and creating new detections or rules, they're sometimes called alerts. It's going to depend on the sim that you're using. But at least in Panther, creating a new detection, you've got a couple different options. So you can use out of the box rules, and you'll likely want to tune those, and we'll get to that on the next slide. You can write totally custom Python rules from scratch if you have a log type that there's no out of the box rule for, or you just don't see the use case in those out of the box rules. And then you can also create new rules with simple detections in Panther. So if you have users who aren't as strong at coding, those rules are still defined in code on the back end, but it gives a GUI to folks to be able to build detections easily. So there's different skill levels that can create a new detection. And once you've done that, then you want to measure the threat coverage of those new rules. So compare with the gap analysis you completed. Did you cover, especially when you prioritize those top priority logs that were missing coverage or use cases that didn't have coverage? You can use framework tools like MITRE. Panther has a built-in MITRE mapping with your detection. So if that's a framework you're leveraging, you can quickly see at a glance where are the gaps. And at the end of the day, generally speaking, you want your data sources to all have at least one detection running against the logs. Sometimes those logs, like Michael said, can be used just for context. You don't want alerts on them, but most of the time, if it's important enough to put in your SIM, you probably want a detection against it. So that can be just at a glance, a good starting point. Just, do we have data we're ingesting and we're not actually monitoring for any threats right now? That's a good way to then kind of reiterate on that cycle.
Yeah, and just to kind of reiterate here, like the out of the box rules are a fantastic start. So when I create new detections, I always look at what currently exists. If I onboard a new log source, look at the base detections that I'm provided, and then I always tweak those in some way, because very rarely is anything going to be complete right out of the gate, right? That makes it a little bit easier if you're leveraging things like helpers that hold things like lists or lookups, or that can reach out and help add that context. But yeah, absolutely think that's pretty critical. And then in terms of measuring kind of the coverage that you have, or trying to gauge your maturity against like how advanced are my detections, right? Like obviously your gap analysis is your most important thing. You want to be ingesting the important sources, because then it doesn't matter how well your MITRE framework mapping is if you're not actually logging the most important sources, right? So making sure you have the sources you need and want, and then having some way to measure those. And I think MITRE is generally a pretty good way to do that. So yeah, I think that covers. All right. Yeah, so similar to what we were just talking about, like you're going to be tuning alerts, whether that's something that you are tuning out of the box to make them work in general against your data sources, or whether that's to reduce false positives generally, right? We talked a little bit about the prioritization piece and the need to reduce false positives. I don't think anybody who's worked in a SOC or has ever had to triage alerts has ever had the thought like, okay, this is a number of false positives I'm good dealing with. Like, there's always room for improvement there, because that just means more time freed up to do the actual work you need to do when you identify valid findings. And then you also get to do the fun and cool engineering projects that you get to do when you're not triaging alerts. So obviously high false positive rates are going to be a key indicator of an alert that needs to be looked at. The other thing we wanted to bring up, just because it's part of the whole incident response process, right, is that lessons learned piece, right? You're going to look at incidents and you're going to be like, this happened, did it trigger somehow? Was it reported? by a person, or was it triggered via, a tool? Did we miss this somehow? Look at your incident history, look at your findings, see how it got either through or missed, or again, maybe it's a piece of software that we didn't have in a log inventory. Use your incident history as a source of data for determining what you need to prioritize. You might find that there's you know, what you considered a low priority log source has been a part of, 6 out of your last 10 incidents. And so you want to ensure that that gets covered. And then so the actual reduction of noise when you're talking about in particular false positives, but just in general with alerts, right, is really going to be about just the process of going through and looking at it and saying, what's the logic here? Let's tweak that in some way. Let's see if that does the trick. We'll do, back to that testing piece, like run it through the tests. Does it still pop? Is it doing what you expect it to do? Is it catching the things you want it to catch? Is it leaving out the things you want to leave out? So always, you can iterate through that process of really looking at just the, analyzing the logic and tweaking the definition, tuning it, and, just that cycle. And then, with a lot of SIMs, you're going to have some basic aggregation and deduplication, and whether that's a static threshold or whether that's a string per user or something, if you're seeing a lot of false positives, double check that. Are you seeing a lot of repeats? Can they be aggregated differently? Can the deduplication threshold be set, right? Those are some real simple things you can do to just help drop some of that threshold if you're seeing especially repeat type alerts. And then improving context. I think I talked a lot about that. I won't go into huge detail here, but bring in alerts and contextualize, or bring in sources of data and contextualize your alerts. That is the biggest win that you can ever do. And DAC, detection as code, really makes that a lot easier than standard tooling. So yeah, the how-to, we covered some of it, right? If you got detection as code, edit the Python. Use out-of-the-box detections as a great starting place and tweak those as you see fit. There's the filter is there, right? If you don't want to deal with Python, or if it's a quick fix where you're looking at like, hey, let's exclude this particular user, or let's exclude this field or this group, just apply a filter. It's a fantastic combination between the logic and the filters. So yeah, it gives you super powerful stuff, but also a real simple and easy way to quickly adapt.
Okay. Yeah, a couple examples of detection tuning, just to put it in even more tactical, actionable terms. So let's say a good use case for using just a filter, like Michael was just saying, if you are monitoring for traffic on a specific log source that's taking certain actions, you might have an HQ office. You can apply an IP filter for that IP. Okay, if people are logging in from there, we're not worried about it. Or if you have, a couple different offices, you can add all of them as a filter. So that's a really good example of just a quick tune where you don't want alerts for known IPs with your web traffic. Dynamic roles. So this is going to be more in the Python itself. A good example that we come across a lot are actions that could be high risk depending on who's doing them. But if it's from an expected user, it's not a concern. So you can use dynamic severity. So the classic example is HR or IT, they're onboarding the users, they're provisioning or deprovisioning access. That's not a super high risk action from those people. That's their job. But if I'm as a product marketer deprovisioning or provisioning user access to users, that's something our security team would probably want to say, hey, Katie, what are you doing? And get an alert on. So that's a really good use case for dynamic severity and tuning that.
Cool. The last one I'll take. So call that one, it's caching, but it's the kind of Panther language for it. It's the ability to basically store data or historic data or reference previous data while you're looking at real-time alerts. And one of the use cases I use this for, and that's been really powerful, and I kind of referenced this before, is just baselining historic role assumptions for certain departments within and individuals within the organization, right? So getting a historical chunk of data that we can leverage for anomaly detection, right? And so we have this piece where um, the alert started out as just let's flag on all of these critical roles, and anytime they're assumed, or we will take a look at those and verify that, as you I'm sure imagining, gets old pretty quick. And so we needed a way to kind of tune those out, and we leveraged Panther's built-in sort of caching for that. There's like string sets and other like DB lookups and stuff you can do to kind of track that historical data when you're looking at real-time alerts in a way that you won't need to necessarily resort to like a scheduled query for, but it still gives you that, and it gives a really great way to leverage historical data to do computational statistic-based thresholds as opposed to just arbitrary, like, I don't know, this many per day seems good, right? It gives you the basis to start doing some more concrete analysis of the events.
All right. So just to summarize that workflow we just ran through on those last few slides. So thinking about this detection as code workflow, it really is a flywheel, and it's never just a one and done process. You want to analyze the performance of alerts. You want to analyze the gaps in your coverage. You want to create detections based on that. Then you want to continue to tune those. And then you want to test and iterate and continue the cycle. So you can always be improving that detection engine. I don't think there's anyone who feels like it's perfect. There's no new rules they need. All the alerts are flawless. So always be kind of following that workflow. And I just wanted to create this visual to show what that cycle looks like. And just kind of in summary, as we get to the end and Q&A here. So we just talked through a lot of different elements and how to use detection as code and what the benefits are. But really the 4 key things we wanted to pull out. You're like, first and foremost, you're going to have better security. Your security posture is going to increase by using this approach. Enhanced detection and response. We just went through so many different ways that you can improve that process. More dynamic and capable alerts, which in turn delivers increased alert fidelity.
Yeah, and I think this is especially important when you consider, like I said, I am at Zapier for the last handful of years. I've had a very small detection and response team. And so leveraging the sort of dynamic capabilities of a detection as code setup as our SIM has helped us really hit these in a way that allows us to scale our detections without having to scale our people necessarily. So, and yeah, I think it's an important piece to call out.
Yeah, nice. So we are going to dive into Q&A. And thank you everyone for your questions. If you have any more, keep submitting them. The door's not closed. So let's start at the top here. How do you integrate detection as code into other systems like a SIM?
Cool. So we leveraging Panther, like detection as code is our SIM. We use that as really the core basis of our alert definitions and our logic, and kind of where we go to initially when we start correlating events and alerts, right? Having that capability. Now, where you might be able to do something similar is if you're using a more traditional SIM and you're trying to do some sort of code-based aggregation or detection or something else within the pipeline that doesn't quite fit the Panther model. I could see the benefit of that being almost like a middleware layer between your log ingestion and your SIM output to do some of those features of that aggregation or analysis, the parsing, the sort of switch there. So we kind of do something similar in that even though we have detection as code, sort of, our detections are literally just the Python-based ones and some of the simple out-of-the-box ones and some YAML queries through Panther. We actually built a secondary tool because we realized we're doing a lot of programmatic outreach to like these other tools like Okta or our G Suite logs or, other admin tooling and like aggregating like point in time context. We created a secondary tool that's like our single point of outreach for that. So Panther reaches out to one tool and that tool reaches out to these other ones. And so I would imagine integrating your own sort of custom built DAC solution, or is an offering is sort of a middleware in that regard with the traditional SIM approach. Hopefully that
How,
answers it. Feel free to add anything if I didn't cover or the context was different.
how does detection as code affect the performance and how does it scale?
All right. I actually, the predominant work I did previously was in Splunk, so I will compare to that. And the performance of detection as code I find to be incredibly fast, and it's near real time. Because, and it's less, I think, a product of the detection as code and more of just a product of solution architecture, right? We're not running, in the event of, like I said, using previous experience, we're not running multiple subqueries on a massive data lake. That's something that will take time. With the detection as code approach, you're generally analyzing events as they come in based on the data there. And then even reaching out to our other tools and stuff, on a slow day, the response might be measured in seconds at the worst. So just generally, it doesn't have a negative approach to the performance at all. I think that's in terms of time-based performance. I think in terms of analytic performance, it blows it out of the water compared to traditional sort of approaches. Just like I said, given some of the capabilities of like a known generalized scripting language that any engineer worth, you know, worth their salt has had some experience with Python. Might be, like I said, a 30-minute tutorial on a basic website, but that's enough to get started, right? To start leveraging some cool, string manipulations and weird stuff, or, what you would do in 6 pipes of Splunk language, you can do in a single Python line with much more legibility. So I think in that case, that it kind of works in terms of scale as well. The that helps scale the amount of engineers that can work on a single solution or a single detection logic. But at the same time, in terms of just straight ingestion and how Panther in particular is handling that, really comes down to, again, kind of the architecture. In more monolithic deployments, like, again, my experience with former SIMs, the more you're hammering that, the slower it's going to be, because they're generally hosted on a particular, either self-hosted server or a cloud-based server where you have persistence in your spiking CPU, or leveraging, your maxing RAM and stuff like that. It's generally, I think, the CPU, or maybe the DB access if you're locking. With Panther, it's a lot different. Again, I think more architecturally based, just given the fact that these detections, if I'm not mistaken, are running via like Lambdas, right? They're on demand in their own compute serverless instance, and so you can throw a million of them at it, and you're limited only by the infrastructure of like the largest hosting provider in the world. So, it scales.
Nice. How do you make sure that your detection as code does not introduce new vulnerabilities?
It's a good question. And I think overall, again, based on the architecture of the solution with leveraging Panther, right, it's in an isolated instance. It's receiving our data. It doesn't have necessarily the ability to change anything or call out and interact. Like I said, with that middleware that we created, obviously that's going to be a different piece. Again, it's going to be read only, but it's going to be something you want to stay on top of, predominantly around like custom moves like that. So in that, with our custom solutions, where we wrote that middleware and we leverage that as part of our DSC pipeline, we have that going through our standard vulnerability management process. It went through a full application security review, right? For Panther itself, and leveraging the detections as code feature of that, given its isolation and that it's, point in time, it's not running on a dedicated server somewhere ready to be popped. It's got some of that isolation built into just the architecture that provides that confidence. Panther has also been really good about like addressing when there are vulnerabilities, especially things that might affect an infrastructure like that, they've proactively approached us and like, we're looking at this and we're digging into this, and we'll let you know if there's been an effect. So far, there's been nothing where that's actually been a true case. But it's, yeah, I mean, you're running a SaaS service, you need to be aware of that, especially when you start talking about importing libraries. You want to make sure those are tried and true. And I think Panther does a good job of vetting those. They have some out of the box ones that are common. And I think if you want to do custom ones, I believe that's like a support ticket and you work with them to do it. So it's got to be pretty explicit. You can't just be like, bring in X library and have at it, right? So
Yeah. When it came to choosing a SIM, did you consider how it would work with other solutions in your tech/security stack?
absolutely. Especially for a small team, the importance of being able to onboard logs quickly and effectively was pretty key, right? And for a good chunk of our sources, it's basically like, here's an API key, it reaches out to the tools and it pulls the event streams from them. And so a setup like that makes it super easy. For the more complex setups, we're looking at dumping things to an S3 bucket or blob storage somewhere. And in that case, again, fairly simple. You create a role. I believe that there's been since the time that I onboarded Panther, and now like there's helpers with all of this stuff in terms of like it'll generate a role, it'll generate Terraform changes and stuff like that, so that it's super easy to do, and those rules are very limited. But it's nice. A lot of this stuff handheld, so it's like, all right, API access, S3 ingestion, and then in the not too distant past, it was like, all right, we're going beta on like straight webhook ingestion, which was something I've been looking forward to for a very long time because it opens up the doors for a lot of what would otherwise be pretty complex ingestion cycles. So yeah, absolutely looking at your tool stack, figuring out how you need to access it, especially for those kind of high prioritized log sources is always going to be key.
When you implemented Panther, did you get more insight of gaps that had been undetected from previous SIM solutions?
Uh, um, I'm going to say yes, and only because we actually didn't have an official SIM in place prior to me onboarding and picking one. We had some log aggregation. We had some basic alert capabilities with something like, loosening. We leveraged Graylog for a number of things. And that was our only source of data at that point. And so we were leveraging Graylog alerts and like Lucerne syntax and like the sort of Boolean based searches, which can be difficult to do anything complex. Then you're generally resorting to things like regex searches, and those are going to be computationally intensive and slow searches down. So the onboarding of a solution like Panther to us was pretty attractive in that the ease of setup, the architecture of it, as I kind of mentioned in response to some of these other questions, made it really attractive in terms of scalability, the lack of maintenance, right? It allowed me, I'm not maintaining, I don't admin Panther, right? I write detections. Like the admin piece is like a one and done. So like all of that kind of goes into, in a roundabout way, like we gained insight. I think we chose correctly, but as an honest answer, we didn't have a SIM. So any SIM would have probably given us more insight. I'm super glad we chose Panther for a lot of the reasons that I kind of outlined previously.
How does the data lake included with Panther compare to other SIM solutions maintaining your security logs?
Um, I really am fond of the data lake provided predominantly for, I think there's two major reasons. One, it's super performant. If I'm really lazy about my SQL queries, or like I'm gonna wildcard this and just see what happens and kind of refine from there. It's obviously going to be a lot, depending upon the type of data I'm bringing in. You're going to have to wait, but all in all, it's very performant. Even when I do wildcard queries, I rarely am like, oh wow, I must have really broken something. And in particular, when it comes to defined queries for scheduled searches, I find it to be really reliable and quick once you've got those pieces defined. The thing that might scare some people away is that like if you're not super familiar with SQL, like having to craft SQL queries for things might seem daunting. With the addition, I think, of some of the new search mechanisms that Panthers provided and some of the logic on just simple searching makes it a lot easier. Um, but additionally, I'd say I view SQL as a strength predominantly because when I'm looking at people to come in and have that dual role of analyst and engineer, it's one less specific language that needs to be taught and it's generalizable. You know, you can get help on Python and SQL all day, any day, right? The minute you start specializing more of your language types, you reduce the amount of knowledge that's kind of out there and spread. So I like that it's SQL. I like that it's performant. I like that there's a simplified search on top of it. So I haven't had any issues with it really. It's not something I really think about, but it's good.
Are there any things you'd say to watch out for if someone's considering migrating to detection?
Uh, yes. Test and test again with your logic. If you screw something up and you're a little too wide and you just kind of let it run, you might wake up to thousands of alerts because you forgot to set your initial rule. Like you just forced it to return true no matter what. So it's just every log that came in. So like, you know, test against that stuff, make sure the numbers look okay. Um, and and the other thing I guess would be it's really easy to be really verbose and kind of lazy in terms of writing detections in something like Python because of the million ways you can get something done. So come up with at least some sort of standard or approach that you want your team or your team can agree upon using for something like that, because that way you'll know when to create helpers, how to reference them, you know, how to approach certain things like, you know, when how you want to review data, like bring in data model objects versus like just string objects from the alert. So there's a couple of specific items there, but the biggest warning would be when you when you're setting your let's return an alert logic, double check that the numbers make sense
Yep.
and you're not just forcing it to return true.
Yep.
I say that unfortunately out of experience.
That's a big one. Are there any detections you think work better in detection as code versus scheduling queries or vice versa? So I think like real-time roles versus scheduled roles.
Yeah, that's a great one because it I think the context of what you're looking at is going to determine your approach, right? Anytime you're looking at complex historical lookups, so in our case, when it comes to some of I mentioned like we use individual alerts with like that caching feature to look at an individual's role history. But when we're looking at like the role history of the org overall, or we're querying a lot more data that isn't like tied to the same sort of paradigm as an individual, it becomes a lot more, it makes a lot more sense to view that as a scheduled query. Additionally, given that alerts usually act on a single piece of data, like an ingestion comes in, it meets a rule, and it will go through the detection logic for that rule type. When you want to combine data from multiple like historic data types or your multiple data types, you can do that with a scheduled query and leveraging SQL joins in ways that's going to generally be a lot easier than attempting to build out really weird caching mechanisms to store things from an individual alert perspective. So that's generally how we approach it is we try to go for this single alert so that we don't have to rely on scheduled queries, which are going to have, you know, as they're scheduled, they're going to be a built-in delay. You're losing that kind of real-time approach to things. But there are cases where you're looking either larger or you're combining multiple sources to synthesize an alert to be run after that. Those are going to be, I think, far more effective as scheduled queries.
Thanks. All right, last question. Does detection as code only work if you have dedicated engineers for it?
No, and I'm glad because I don't have dedicated engineers. I've got myself and like two other people on my team. We are the detection and response team for Zapier. And so if it required a dedicated engineer, we would lose 33% of our capability as a team. What's nice is that it um, I kind of mentioned this before, is just the generalizability of something like Python and SQL as a language for engineers makes it super simple for somebody just learning to pick up and get into it, right? Like there's a person on my team that we're training up to be comes from a very analytical based background, training up to be an engineer. And like the Python detection logic in Panther has been one of the ways that she's building up these skills and developing into an engineer. So you don't even need to be an expert, right? You can modify because of the layout and the legibility of the detection logic. Oh, nice. See the comment. Tell Adi I say hi.
Awesome. Well, thank you everyone so much for your questions and for joining us. If you're interested in learning more about Panther, Olia dropped a link in the chat to join for a workshop next week on detection as code. So you can do a workshop, kind of get your hands around it, try it out now that you've learned a lot. And you can also check out our doc, and you can always reach out to schedule a personalized demo on our website. Thank you so much for joining us, and thank you, Michael, for sharing your expertise with all of us. We super appreciate it. Hope everyone has a great rest of their day.
It's been great. Thank you.
Thanks, everybody.